This is Rachel Bixel, Danica Christensen, and Andrew Oborn, and we will be covering Chapter 5, Analyze Telemetry to Better Anticipate Problems and Achieve Goals. We will be talking about Netflix using outlier detection, using means and standard deviations to detect problems, analyzing previous problems to create better future alerts, non-Gaussian distribution problems, anomaly detection techniques. Netflix is a great example of analyzing telemetry to find and fix problems before they impact customers. In 2015, Netflix had a revenue of $6.2 billion from 75 million subscribers worldwide. To provide the best experience for their viewers online, they have to have a robust, scalable, and resilient infrastructure. The problems they faced is finding abnormal nodes within a 1,000-node cluster. To conquer this problem, in 2012, Netflix used detection outlier to detect abnormal behaviors that will result in a major degrade of performance. To do this, they computed the normal state in a compute cluster. Then they located nodes that did not fit the pattern and removed them. The bonuses of doing this method means not having to have operations to do anything and not having to define what the proper behavior of nodes are. Implementing this statistical technique reduced the effort in finding and fixing bad nodes. It also improved service quality, work and life balance, and preserved employee sanity. The easiest way to analyze a production metric is to compute its mean and standard deviation. This helps to create a filter to detect when the metric is significantly different than the norm and creates alerts to take action when this occurs. We can create even better alerts by increasing the signal-to-noise ratio by focusing on data that deviates the farthest from the mean. For example, we can use the standard deviation to be alerted when unauthorized login attempts a day are larger than 3 standard deviations. This technique helps us avoid the impossible task of defining a static threshold value from production metrics that can range in the hundreds of thousands.
When errors occur, alerts often trigger after the fact. However, ideally, alerts should go off before issues happen so that problems can be detected and fixed, mitigating negative consequences. This is accomplished by analyzing recent serious occurrences within the system, looking at the leading indicators that would have given an earlier warning of deviations from standard operations. A list of telemetry should then be created that would have been able to detect and diagnose the issue faster. It's also important to make telemetry that could confirm an effective fix had been successfully implemented. By repeating this process, working first through the most severe cases, then moving to weaker failure signals, problems can be found and addressed early and quickly for fewer customer issues. Although means and standard deviations are helpful, they don't always have the best results when used with telemetry datasets. When data does not have the Gaussian bell curve, like the image here, alerts either fire frequently, since data often leaves the 3 standard deviation threshold, or not frequently enough. While over-alerting causes engineers to receive alerts at all hours due to inconsequential matters, under-alerting can result in errors and system failures that customers discover before engineers do. Using standard deviation with non-Gaussian distribution can also create confusing, nonsensical results. Netflix found a way to combat this by using a tool they developed called Scryer. Scryer predicts customer demands by analyzing past patterns. Since consumer viewing patterns were fairly consistent, Scryer could use this knowledge to put out various data points to smooth the data while maintaining necessary data spikes. This allows Netflix to predict traffic demand with a great deal of accuracy. Scryer has helped Netflix reduce costs while considerably improving the customer's viewing experience.
Not all datasets have Gaussian distributions. In spite of this, we can still find meaningful variances using different methods. These methods are collectively referred to as anomaly detection. Anomaly detection can be defined as the search for items or events which do not conform to an expected pattern. Anomaly detection methods can be found inside existing monitoring tools, while others will require help from people with statistical skills. One such technique is called smoothing. Smoothing is useful when working with data that relies on timestamps or time series. Additionally, smoothing often involves working with moving averages. This means that data is continuously being transformed by other data points within a particular time series or sliding window. This will effectively smooth out short-term fluctuations and highlight long-term trends. There are more anomaly detection methods used. Some are elaborate or exotic, and others may be more simple. Regardless of what method is used, the goal is to find regular and predictive patterns. Because these anomaly detection techniques are useful in forecasting, there may be people in other departments, such as marketing or business intelligence, who have the skills and knowledge to analyze the data. It is a good idea to collaborate with others and identify shared problems and use anomaly detection and analysis to solve those problems. An example of anomaly detection happened at a company called Monitorama. The company was using anomaly detection to track online sales. Whenever an anomaly happened, an alert would be raised and responded to. This allowed the company to discover when there was a drop in sales on a particular day that would have gone unnoticed if a standard deviation method was used. Additionally, the company was able to compare data from day to day or week to week. This gave them a better understanding of sales patterns, which in turn allowed them to respond much quicker to any issues and achieve company goals. In conclusion, we covered how Netflix used outlier detection to find nodes that were lowering performance. They were able to remove these, which improved overall quality to customers and employees. We discussed detecting problems using standard deviation and means and alerting when there is an undesired outcome. We also covered problems that can arise when data does not have Gaussian distribution and how to solve those issues using anomaly detection methods.